Thank you, Uma. Well, good afternoon, everyone. I'm a second-year PhD student here in the campus of Valencia, and I'm doing my thesis based on ecological restoration. Today, I'm going to talk about my latest advances in this thesis, and I want to focus on this theme, the physiological leaf traits of two oak species in response to stress conditions in a reclaimed mine of northern Palencia. Well, this reclaimed mine is called Corcos and is located near Guardo, in the north of Palencia. This mine is surrounded by oak forest with species as Quercus petrea and Quercus pyrenaica. As you can see in the image, after 25 years of this rehabilitation, these oaks haven't been able to colonize this area. And this is due to the limitation factors of the mine environment. We have summer droughts in the months of July and August due to a subhumid Mediterranean climate, along with a lack of edaphic structure of the mine soil. This generates stress conditions that limit the growth and the survival of the oaks. However, there is a solution. When the stress conditions are high, the interaction with nurse species, in this case nurse shrubs as Cytisus scoparius and Genista florida, can help in the establishment of these oaks. This is done with the microenvironmental improvement that these shrubs do, with the soil improvement, the water retention, and the protection against stress conditions. In this scenario, if an oak grows under the canopy of a shrub, it may have better chances to survive than those who doesn't. Knowing all of this, our objective here is to assess the physiological leaf traits of two oak species, the Quercus petrea and pyrenaica, in response to stress under different shrub covers. With this, we want to better understand this interaction between the oak and the shrub, and how the shrub helps the oak. So, for this purpose, we have this experimental design. We have two fenced plots with individuals of Quercus pyrenaica and Quercus petrea that were planted in 2011 outside and under the shrubs. In order to measure this grade of protection from the shrub, we categorize and measure leaves in 3 shade levels: light, shade, and total shade leaves, depending on the shade they receive from the shrub, from the individual itself, or from both of them. We collected a total of 150 leaves from both species, and we did the sampling in 3 summer stages: early, mid, and late summer in this year 2024. For the sampling data, we collected some parameters from these leaves, as the photosynthetic efficiency, the stomatal conductance, the leaf water potential, the leaf area, and also the dry and fresh weight. For the data analysis, we computed some parameters that we need for the results, as the specific leaf area, the leaf dry matter content. Also, we follow the Grimes CSR theory for the plant strategies that I will explain better in the results. For the statistic analysis, we use linear mixed models and the StraightFi tool to categorize these plant strategies. So, now with the results. First of all, we did some testing on the fixed effects and their interactions. These fixed effects are the Quercus species, Petrea and Pyrenaica, the time of the summer, and the level of shadow they receive. These fixed effects were tested on the leaf traits that we measure on the leaves. You can see in the table that the shadow is on yellow because I want to focus now in this effect, because now is the most important one. And these are some results. I want to show you first the difference between the light leaves and the total shade leaves, as they are the 2 extremes. And we see these results. First of all, we see that the values of leaf area and specific leaf area tend to be lower in the light leaves, showing that, these leaves tend to be smaller and thicker, in contrast with the total shade leaves that tend to be larger and thinner. Also, with the leaf dry matter content, we see, in contrast, high values in the light leaves, showing drier leaves in the light than in total shade. For the stomatal conductance, we also see higher values in the light than in total shade. And finally, for the photosynthetic efficiency, there is no graphic, but we know that values under 0.79 show the stress of the leaf, and these values tend to be lower in the light than in total shade. With this, we can confirm that, well, by the moment, these light leaves are in higher stress than the total shade leaves. Remember, these light leaves are over the shrub canopy and they're not protected by the shrub, in contrast with these total shade leaves. Continuing with the results, we follow the Grimes TSR theory on the plant strategies. This theory is originated with this representation you see on the right, this graphic, with the representation of the level of habitat disturbance and the level of stress of the habitat, knowing that no species can survive in an habitat with high level disturbance and high level of stress. With this appears this triangle with the different plant strategies species can have, where you can put all the traits or the species in order to identify some difference between them. It will be C for competitive, R for ruderal, and S for stress tolerant. So we wanted to interpret our traits in this triangle, and for this we needed the trait of leaf area, a specific leaf area, and leaf dry matter content. With the help of a straight phi tool, we made our triangle. You can see in the caption that all the fixed effects are compared here, the shade level, the Quercus species, and the summer stage. If we analyze all of these traits all as one, and interpret their position in the triangle, we identify that the leaves from both species are mainly stress tolerant and slightly competitors. But we also did some analysis here, and we mainly analyzed the significant differences in the stress tolerant range. To show you these differences, I rotated the triangle so you can focus on this range here, the stress tolerance one, and we see some difference here. First, the Quercus petrea in total shade and measured in the early summer tend to be less stress tolerant, as they are more near the 50%. In contrast with the Quercus pyrenaica, most of them light leaves in the late summer tend to be more stress tolerant, as they are more near the 80%. With this, we can see that if we look closely, there are some difference between species. Well, to conclude some results, we know that light leaves suffer more stress conditions than total shade leaves. Also, both oak species tend to be mainly stress tolerant and slightly competitive. But if we look closely in the differences, we see that Quercus pyrenaica light leaves are more stress tolerant than Quercus petrea total shade leaves. With this, we can say that, well, yes, shrubs reduce the leaves exposure to the stress condition with the microenvironmental improvement. But we can't forget that this also depends on the type of species we have and the season stage that we measure this. All in all, I think we can say, yes, nurse shrubs are an appealing option for degraded habitat reforestation in future techniques. This project doesn't end here. We are focusing on a new XC2 experimental design that we are doing in the campus of Palencia. You may have seen these cages we have here in this building. For this, we collected 300 acorns from the surrounded forest of the mine, from both species, Petrea and Pyrenaica. And now we are measuring the germination rate, the emergency rate, and the percentage of survival. When these seedlings establish, we also want to simulate the 3 shade levels that we have measured with the shrub, simulating this shrub canopy, and also 2 watering levels to simulate the water stress that they have in the mine. When we have this, we want to also measure these leaf traits. Maybe in 1 year I can tell you about this. Now it's time to wait and to continue analyzing. This is all for now. Thank you everyone for listening, and thank you to my Restore Mine team.